If you can hear my voice right now, if you're listening to music, or even just noticing the sounds around you, you're experiencing the work of a sound engineer.
Right. It's this hidden world that's all around us.
And it's not just about pushing a button. We're going to break down what a sound engineer really does. They're these experts who handle all the technical stuff, from recording to broadcasting.
And that's the key, isn't it? It's this wild combination of skills. You need a really creative ear, to know what sounds good.
Yeah.
But you also need a deep, deep understanding of electronics, of hardware. Their main job is to take all these sounds and make sure everything is perfectly balanced.
And you find them everywhere. Music studios, huge live concerts, on a film set.
Absolutely. You always picture them with those big headphones on, staring at this complex control panel.
That's the one. They are basically the conductors of everything we hear.
So to really get what they do, we have to start with the basics, the raw material. We have to talk about the science of sound itself.
Okay, where do we begin?
Well, sound is really just vibrations. When I speak, these invisible waves are traveling through the air to you. An engineer's job is to turn those physical waves into electrical signals. And the way we measure them is in hertz, or hertz.
Which is just how many times a wave repeats per second, right?
Exactly.
Something high-pitched, like a whistle, has a ton of waves per second.
Right. And something low, like a bass guitar, has way fewer.
That makes sense.
And for humans, the general range we can hear is about 20 hertz, which is a rumble you almost feel, all the way up to 20,000 hertz.
And don't we lose the ability to hear those super high frequencies as we get older?
We do. And that's something an engineer actually has to think about when they're mixing.
So how do they use this knowledge? I mean, what's the practical application?
Okay, so say you have a recording with an annoying buzz, or maybe the singer's voice is getting buried in the mix.
Yeah.
An engineer knows exactly what frequency that buzz is, and they can just cut it out. Or they can boost the specific frequencies in a singer's voice to make it stand out and sound clear.
So they're not just turning things up, they're carving out space.
That's the perfect way to put it. It's about clarity, not just volume. Making sure every instrument has its own little pocket to live in.
Okay, that makes it sound a lot more like sculpture. So let's get into the tools. The command center for all this has to be the mixing console, right?
Oh, absolutely. It's the central nervous system of the whole setup.
And its job is basically to take all these different audio signals from all the mics and instruments.
Sometimes hundreds of them.
Wow. And it combines them into one final output.
And when you look at one, you see all those sliding things. Those are the faders. That's for volume. Then you have all the knobs above them, and those are for changing the tone, adjusting the high and low frequencies we just talked about.
But hold on. With powerful computers and software now, why do you still see these huge physical mixing boards?
That is such a great question. It really comes down to workflow and feel. A lot of engineers just prefer having a physical fader to grab onto. It's immediate, it's tactile.
You're not clicking with a mouse.
Exactly. And some of those old analog consoles add this certain warmth to the sound that software has a really hard time copying perfectly.
Got it. So all those signals coming into the console have to start somewhere. Which brings us to microphones.
Yep. The device that turns the sound waves into electricity.
And I've heard there are two main types. The first is a dynamic microphone.
Right. Think of those as the tanks. They're super durable, you can drop them, and they're great for loud stuff like drums or a guitar amp.
Okay, the workhorse. What's the other one?
The condenser microphone, these are way more sensitive and detailed. They need their own power source to work.
So you'd use these for, like, recording vocals in a quiet studio?
That's their sweet spot, but just picking the mic is like step one. Where you put it is everything.
What do you mean?
Every mic has a pickup pattern, which is basically the direction it's listening in. Some listen only in front, others listen all around.
So you have to aim it correctly.
And here's the crazy part. Moving a condenser mic even 2 inches closer or further from a singer can completely change how their voice sounds. Getting the placement right is maybe 80% of the job.
Wow. And all that sound needs to get from the mic to the console. So,
cables.
the unsung heroes. And in a pro setup, we're talking about the XLR cable.
The one with the 3 pins.
Exactly. And those 3 pins are genius. It's called a balanced cable. It basically carries 2 copies of the signal.
2 copies.
Yeah, one is phase reversed, and any electrical hum that gets picked up along the way is canceled out at the other end. It's a super clever way to get a clean signal over long distances.
That is clever. A built-in noise reducer.
Pretty much. Of course, you also see the 14-inch cables, for electric guitars and stuff.
But the real skill is just keeping them all organized, isn't it?
Oh, 100%. A single bad cable can cause a huge pop or just kill the sound entirely during a live show. It's a nightmare.
Okay, so let's move from the physical world into the computer. We have to talk about digital audio workstations, or DIWs. The DIW. Yeah, this is where most of the work happens now. Programs like Pro Tools, Logic Pro, Ableton Live.
This is the software where you can see the sound
Yeah.
as a visual waveform.
Yeah, and that changes everything. You can see a mistake, a cough, or a wrong note, and literally just cut it out. You can move a whole chorus from one part of the song to another.
Without having to re-record the whole thing.
Exactly. And this is what made it possible for people to make amazing sounding recordings, even in a home studio. It's incredibly powerful.
And once the audio's in the computer, you can start adding effects.
This is where the real magic happens. It's called signal processing.
Let's run through the big ones. First up, EQ, or equalizer.
That's just adjusting those frequencies we talked about earlier, carving out that space for every instrument.
Then you have the compressor. What does that do?
A compressor evens out the volume. So if a singer is quiet in one part and then really loud in another,
The compressor smooths it out.
it just makes the performance feel more consistent and punchy.
What about making things sound like they're in a big room?
That's reverb. It can make a vocal recorded in a closet sound like it was sung in a giant cathedral. And delay is just its cousin, which creates an echo.
So you have all these powerful tools.
But the real skill is knowing when not to use them. A good engineer enhances the performance. They don't make it sound fake or unnatural. Restraint is key.
So after all this processing, how does an engineer even know if what they're hearing is real?
That's where monitoring comes in. It is critical. You can't use regular headphones or speakers
Why not?
because most speakers are designed to make music sound good. They boost the bass, they boost the treble. Engineers use special speakers called studio monitors. They are designed to be brutally honest. They have a flat response, so you hear every single flaw.
So if it sounds good on those, it'll sound good anywhere.
That's the idea, and you have to set them up perfectly. The two speakers and your head have to form a perfect equilateral triangle to get the right stereo image.
Okay, that's super precise.
Yeah.
But even the best speakers won't work if the room itself sounds bad, right?
You are one step ahead. That's acoustic treatment. All those foam panels you see on the walls in studios, that's to control the sound waves and stop them from bouncing all over the place and creating echoes.
So it absorbs the sound.
Some materials absorb, like foam and bass traps. Others, called diffusers, scatter the sound to make the room feel more natural and open.
And this is different from soundproofing.
Completely different. Soundproofing stops sound from getting in or out. Acoustic treatment controls the sound that's already inside the room. You can have a totally soundproof room with awful acoustics.
Got it. Okay, so let's put all these skills together. Where does an engineer actually work? Let's start with a high-pressure one. Live sound.
Live sound is a whole different beast. You're managing audio for a concert in real time.
No second chances.
Zero. If a mic starts making that awful feedback screech, you have to fix it in a split second. You're managing massive speaker systems for thousands of people.
And the main engineer is usually out in the audience, right? In front of house.
Yep, they're mixing for what the audience hears, but there's often another engineer on the side of the stage.
The monitor engineer.
Exactly. Their job is to make sure the musicians on stage can hear themselves. If the singer can't hear their own voice, the whole performance falls apart.
That sounds incredibly stressful.
It is.
Okay, let's switch gears. What about sound for movies and TV?
Totally different goal.
Oh.
There, it's all about capturing clean dialogue and then building a believable world with sound.
So on set, you have the boom operator holding that long microphone pole just out of the shot.
Right, but so much of the sound is actually created later.
You mean like Foley?
Exactly. That's the art of recording sound effects in a studio. The footsteps you hear, the rustle of clothing. That's often someone in a studio stomping in a box of gravel or rubbing two pieces of fabric together.
No way.
It's amazing. Then the final challenge is mixing in the music. You want it to be powerful and emotional.
But you can't let it drown out the dialogue.
That balance is everything. It's a true art form.
So when you look at all this, the career paths are just huge.
They're incredibly diverse. You can be in a music studio, you can tour the world with a band, you could work on video games.
Video game audio must be huge now.
Oh, it's massive. Or you could work in broadcast for TV and radio. A lot of engineers are freelancers too.
And how do you even get started?
A lot of people go to technical colleges to learn the science and the gear, but honestly, the real learning starts when you get an internship. You have to learn from people who've been doing it for years.
So it's technical skill, a good ear, and also people skills.
You absolutely need all three. You're dealing with artists, after all.
It's really a job built on tiny details, where moving something a couple of inches can change everything.
Okay.
So here's a final thought. With AI getting so good at automatically mixing things, do you think the engineer's job will change? Will it become less about the technical stuff and more about just having good taste?
I think that's the big question everyone's asking. The tools always change, but I don't think you can ever replace the need for a human's critical ear and, their artistic decisions.
Keep luck with your studies.
See you next time.